Link 341. Hello and welcome. We're back into the grad's office where there is a loud fan in the background, but hopefully my voice will reach you. So today in this presentation, this lesson, we are going to talk about glides plus secondary articulations. Glides are also known as approximants, and we know how to produce them. We approximate one articulator next to another. So we basically have this kind of controlled effort there and controlled articulation in that our tongue, for example, reaches a palate. It doesn't touch it. It doesn't create a turbulence noise. It doesn't create a narrow channel. It is just closer to it than it would be when we are talking about, for example, vowels. Sometimes approximants or glides are called semi-vowels, so these are vocalic sounds where you can get pitch, where you can get F0. So approximates, one articulator is close to another, but without producing audible turbulence to make them fricatives, right? That's why we have that difference in approximants. They come in two flavors. There are English glides, such as w and y, and there are liquids, such as and l. And we'll talk about liquids in our last lesson. This distinction is also phonological. Glides are essentially high vowel articulations which are not in a syllabic peak, right? So this is what you need to understand, that they are not syllabic, they cannot be syllabic, but they have certain vocalic properties. In English, liquids may form syllables or syllable peaks. So these are the two types of approximants. Glides across the world and in English are the following: yeah,
yeah, yeah,
okay, what,
yeah, yeah, what, yeah,
okay, this does incorporate. What? Then we have
yeah,
yeah, right? Front rounded one, a labial palatal. So basically, you are having your lips rounded and approximating your tongue towards the palate. So
yeah,
yeah, right? And velar, right? And this vowel is similar to this velar glide, which is basically the same as the back vowel, unrounded vowel, but with a more approximation towards the velum. Right? Almost sounds like a fricative, right? French contrasts palatal, palatal and labial velar glides. So these are some French glides.
Miette,
Mie,
muette,
mie,
mouette,
ouais,
lié,
lié,
lui,
lui, or lui,
louis,
right? So the rounding gets much greater with this one, with w,
oui,
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 right? And Japanese has velar vowels, but not necessarily velar glides.
si,
And it might sound like this,
si,
right? So these are the glides. Glides are shorter than vowels. They also tend to lack steady states and exhibit rapid transitions. So how are we going to notice them on a spectrogram? And what are their spectral properties? Well, they're shorter than vowels, they lack steady states, and they exhibit lower intensity, which we will see now, especially in higher formants. So this is aya,
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 aya, right? So this is what it would sound like. Let me try record these. Okay. Aya. Aya. Okay, let's see what we got from the. Okay, let's see first this one. So
aya,
yeah, yeah is basically similar to this one here that we can see. So it has the transition to F1, and F1 does not go low as it would for E. I presume we'll see E later. Also, the voicing bars here are not as intense as for E, and the formants are not as intense as for E because of the formant frequencies, which are smeared, right, a little bit for E. Let's see E, how that looks like, right? So for E, you can see the difference there. These formants are much steadier. Formants are also, F1 is a little bit lower and F2 is a little bit higher, and the intensity is quite vividly different from the yip counterpart. And the transitions, as I said, they're shorter first of all, and the transitions are much more abrupt, I guess, or the transitions start earlier as well. So all of these cues, like for these two here, indicate that this is a semi-vowel, which we call also y or glide y, and e, which is a vowel. Then we have awa,
awa, aua,
awa, right? Whereby for w, essentially because it's a back, right? It's almost as if you are making a back vowel, high back vowel. So both w and y are similar to high vowels, right? But w is a back vowel and y would be front vowel, which means that F1 goes down for both of these, right? Here, but F2 goes down for w and F2 goes up for y. So there is a distinction. So F2 goes down for w and F1 as well, and it looks like a w. However, as well, we can see in F3 especially that there is not a lot of intensity there in the formant frequencies as well. So they are smeared a little bit or to a greater extent. And there is a little bit of lip rounding here going on as well with w. With u as too, but maybe with w is more prominent in this case. Right. I think that would be one of the clues you have to look at. These are a little bit creaky.
aua, awa,
Wow. Let me try it out. Awa, aua. So these are different, right? Because you do different gestures. You make different gestures with your articulators. So this would be
awa,
what you see my F3 is even not visible here, and F2 lowers down quite a bit. F1 as well. For E, E is longer. I can see that, right? And sorry, U is longer. We can see that, and more intense, right? Okay, so these are the basic differences between the vowel and a glide. Now, a vowel in a sequence of vowel, glide, vowel, you can really see how that looks like. So,
ee,
okay,
ee,
ee,
ooh,
ooh, right? Let me give it a shot. Ee, ooh. Okay, I don't know why I repeated the intonation as well, but that's okay. All right, so you can see ee, that for E, and then y, right? E part. For E, the formant frequencies are quite more observable. F1, F2, F3, right? For Y, they are less intense, so there is less air being produced, right? Being let into the air. And you can see even here that the intensity is or amplitude is lower, and when amplitude is lower, then these are not as loud as E. E is louder than Y, right? Because of the tongue approximation for Y in comparison to E. Okay, and ooh, yeah, yeah, you cannot see maybe F3, but F2 is and F1 are overlapping each other, so they are sitting. F2 is sitting on top of F1, and there is this segment here where the intensity is much lower. So you can even maybe show intensity. Yes, so you can see ooh, higher intensity, and what lower intensity, right? All right. So those are some cues for vowel glides and vowels, and there are these glides, of course, are paired up with other vowels, not just with vowels that have a corresponding sort of height and frontness and backness. Sorry, they are also paired up with, for example, we, and we is a high front vowel, so that means that F2 will increase, and for w it won't, right?
We.
Right, and that's what we see here, whereby w segment for w, you can see how low the F2 is and how, yeah, F1 remains the same, but it's still a little bit higher, right? Then for E, the F1 goes down and F2 rises, right, very quickly. And this transition is what we hear as w. For U, for example, the opposite pattern happens.
You.
Right? U lowers down the formants, right, the formant frequencies, but Y, Y is high front sort of vowel or semi-vowel. In this case, of course, glide. So Y would be would have this high F1 and high F2, while U would lower them down. All right. So these were glides, and now I'd like to transition to secondary articulation. Secondary articulation is made by superimposing a glide-like articulation on top of another constriction elsewhere in the vocal tract. That's why we're talking now about secondary articulation. Note that secondary articulations are different from double articulations. In double articulations, both constrictions are of equal degree. For example, labial velar stop, like p, 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 right? They should, in principle or in theory, be produced at the same time. Maybe k is being produced a little bit earlier than p, but still, in principle, that's what happens. With secondary articulations, there are two constrictions with unequal degree of closure. So there is primary articulation and secondary articulation, more constricted and less constricted. One example of secondary articulation is velarized ol. So this is a more traditional way that we learn how to transcribe velarize ol. But this is in principle the way in the IPA, right? So for velarization, we use this kind of a velar fricative, right? Right? That's velar fricative, and that's why we are using velar fricative. So primary articulation would be l, right? Direct contact with tongue tip, and the secondary articulation would be this velar fricative, approximation of velum with back of the tongue. So maybe it's not even a fricative in this case; it's an approximant, more so because you don't have time to make a fricative. But this is what we can represent it from now on. But if you use a tilde, that's okay. The other commonly found secondary articulations are w, labialization, palatalization, y, and pharyngealization, right? So this is our pharyngeal fricative, like right? We said you can make pharyngeal fricative if you make it more intense, like right? Something like that. All right. Oops. Labialization. In labialization, lip rounding, specifically protrusion of lips, is superimposed on a fricative or stop constriction. So essentially, you have a stop that is it makes a primary articulation, and a secondary articulation is followed by this wa. For example,
bara,
para,
ba,
wa,
paka,
paka, wa,
para,
para, right? And we'll see later why these are not two different, like puara. No, it's puara, puara,
mara, monta,
manta. Yeah, for these it's a little bit tricky because you're already making a labial sound, bilabial, and here bilabial as well. For this one is a little bit easier.
guar,
Guar, sorry, guar, right?
gam,
Gam,
guar,
guar. So basically, we'll see the timing and why it differs from guar, for example, a guar. So we wouldn't produce or transcribe it like this in this case, right? And because, and the reason for that is for example, is the timing, right? The peak of labial protrusion occurs during stop closure. So the peak of protrusion occurs during stop closure. In principle or in theory, these two should occur at the same time. And for qu transcription, these two should not occur at the same time. So not at the same time, and these two at the same time. However, we in principle have this labialization slightly bit later, right? Then we are producing k or any other stop. Still, it's pretty close, right? And that's how we distinguish between qu and qu, right? Qu, qu, quap, and quap. And we can hear that and see that on this spectrogram or on these spectrograms. For example, for m,
mara,
we didn't do nasal acoustics. We'll do that next time or in our next video, next class. This is a nasal part, right? And before the start of the vowel, right? And we can see, oops, what am I doing? Okay, we can see that there is a transition from m. Or nasals are essentially vowel-like, but with much smeared form and frequencies or intensities of the form and frequencies. And we can see that for mara, there is a transition to a, right? Both formants are high, so somewhere here and here. And for monta, we can see that second formant starts really low because of this lip rounding, and we said the rounding of the lips would produce this effect of lowering your formant frequencies, both first and second, but especially second frequency. And then it goes on to reach its desired value, right? Mara and manta. It is hypothesized that Proto-Indo-European had a series of labialized velar stops. For example, qu, quh, gu, guh, right? Over time, some Indo-European languages maintained the velars, while others maintained the labialization. For example, Germanic maintained the velar, such as ku, which is cow, and Latin maintained labialization, both, which English later, took over from Latin and made a word bovine, right? Old English actually used this word quequello, right, which meant wheel, and with certain changes in speech throughout history, it became huel. In Greek, it actually maintained this velarized version, and it became kuklos, which is a word for cycle, and cycle comes from Greek. The word cycle comes from Greek. All right. Palatalization is quite a common phenomenon as well. For Palatalization, consonants are palatalized by making a secondary y constriction. Russian is famous for its palatalized consonants. I know that at one point Steve asked me that if Serbian has palatalized consonants. I told him not really. It has consonants that became definitely palatalized, but without this secondary articulation, so secondary constriction. Those are the now affricates and consonants, full consonants, which are in my name, for example, Nikolic, ch, basically from t, from this one here, that's tетя, right? But here it's a little bit different because for my surname, with or basically producing a palatalized consonant technically, but this consonant is not considered to have a secondary articulation, right? It only has a primary articulation. Okay, let me show you that. Maybe this one.
Cha, a cha.
That would be the sound in my surname.
Sha, a sha.
No. So yeah, this one.
Cha, a cha.
Which is an affricate basically, right? An affricate, right here. Okay, so that's what happened in my language, but in Russian, we have sok,
сок, сёк,
syok,
зов,
zov,
зёв,
yev,
пакт,
pakt,
пять,
yat,
был,
bil,
бил,
bia,
тот,
tot,
тетя,
тетя,
дома,
дома,
дема.
Yoma. Yeah, the acoustic effects of secondary articulation operate in reverse when they appear after a vowel. So we have basically
Тот,
tot, right? A little bit of aspiration here, and
тетя,
tетя. When they appear after a vowel, we can see the increase in F2, right? And here the increase in F2 as well, because of this y, or palatalized effect. There is also pharyngealization of consonants. These kind of consonants are popular in Arabic, which does have pharyngeal fricatives. So consonants are pharyngalized by superimposing a pharynx narrowing gesture on the regular consonant articulation. So instead of s, your tongue is backed up a little bit, even more so, that it creates this pharyngeal effect, right? And in Arabic there are numerous examples such as
Tin,
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 tin, right? For this one you're almost producing a low back vowel, right?
tin,
Tin, and I mean, not really a vowel, it's actually fricative, but let's see the effect of that on our acoustic
dal,
spectrum. Dal,
dal,
dol,
sus,
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 أتل,
attal,
أطف,
attar,
مد,
mad,
مض,
mad,
مس,
massa,
مص,
masla, right? So he sucked, and I think this is a good example of sucking a little bit of your tongue towards your throat. And these are the representations, as I said.
tin,
Tin, there is an aspiration with T here, and here
tin,
turn. We can see the transitions actually from low to high to reach this E, and here there are no transitions just because of the fact that there is no pharyngalization. If you're pharyngalizing something, then your F1 and F2 will be low, or actually F1 will rise, will be a little bit increased, like here, you can see it here, and F2 will be lower, right, as if you're producing a back vowel, right, a low back vowel, and all like formant pattern, and that's why I said it resembles ah or ah on the spectrogram, right? Okay, that would be all for me now for secondary articulations. See you in a bit with nasals.